times where you use the substitution method, and again, there was some sort of way you could make the ugly algebra substituted out with u. Notice on this number 27, x plus 3 to the 1/3, and then here it is repeated, x plus 3 this time to the 2/3. We say that that is quadratic in form. It's not a true quadratic right now, but we can kind of pretend it is. Call that u or x or whatever letter you like, and that's the square of it. So I'm making note that I'm going to call that a different variable, a substituted variable, and then if that is u, this is the square of that. So I can write this as u squared plus 2u minus 15. And then solve it like I do a quadratic by factoring or using the formula. And get my u solutions of -5 and +3. Okay, but again, multiple choice test, that may be a choice. Don't stop there, you're not finished. That's just u, the pretend solution. We need to then unsub and make amends for what we've done here. U, or the input variable, what it really was is x, needs to be solved for. So we still need to undo this stuff that we were ignoring. You know, we was kind of ignoring that for a minute. I didn't want to deal with the 1/3. I didn't want to deal with the +3. So now I need to cube each side and -3 to fix this part. You know, solve that intermediate part. Okay, so cubing undoes the 3rd power. Cube each side makes x plus 3. -5 cubed is -125. And then minus the 3. And then x, the real value, the real variable we were trying to solve for, right, the original problem is x, so I need to be solved for x. Same thing here, I'll cube both sides, that'll make that 27, and the cubing of that will undo the cube root, or the 1/3 power, and then -3 to make that 24. And then, if you're really being good, you check those answers, make sure that they work back in the original problem. Okay, both of those are okay. Okay, number 28, we're going to do kind of the same thing on that. We're going to pretend it's a quadratic, even though it's really not to the 2nd power, it's to the 4th power. This is a 4th degree polynomial. We're going to study those in the next chapter. So we should be looking for 4 solutions for a 4th degree equation. But don't exactly know how to factor that or anything right now, so I'm just going to pretend it's quadratic and say, let u stand in for x squared. If that's u, that will be the square of it. You know, x squared squared again would be x4. So if I pretend that's just an x or just a u, then that will be the square of it. And so now the problem, I'm pretending it is quadratic, so I can get that factor. U minus and minus to get a positive on the end, but still get a negative middle term. The first thing that comes to my mind when I see 72 is 8 times 9, and so it looks like that maybe that's what I need to be doing. And 80 times 9 would make it a 720. And still give me the -80, -9, right middle term. Then set each part equal to 0 to solve. That gives us 2 solutions of 80 and +9. So make sure you fix that back into its real value. U stood in for x squared, so x squared is 80 and x squared is 9. I'll do the easier side first. X squared equals 9 can be solved by square rooting both sides. But when you take the square root, you have to say plus and minus. So plus minus 3. So 2 answers for that. 3 squared is 9 and -3 squared is 9. Same thing over here for the 80. We'll square root each side, and x is plus and minus square root of 80. But this one will reduce a little bit. You know, it's not perfect like the 9, but we can break out of it a perfect square. Some of you all, and I like this, it's just the absolute way to get the answer. Break 80 down with a factor tree into its prime parts. And then any set of 2, you can bring out one of those. Since it's a square root, a set of 2, like 2 squared, when you square root it brings out just a 2. And then we've got a set of 2's there. So I'm able to bring in a 2, another 2, which makes 4, and there's a 5 left over. So that should reduce to plus and minus 4 radical 5. 1, 2, 3, 4, 4 solutions to our 4th degree equation. Okay, number 29. This time we have a negative 1 exponent, so I want to sub that out with u, let u be the negative 1 exponent. That would be the square of that, so it's kind of quadratic in form again. In other words, on all of these, you pretend they're quadratics, and then you fix whatever you were pretending, you know, you undo that. So in this case, I'm pretending I'm kind of ignoring the negative 1 exponent, so when I get my answers, they'll need to be flipped. The negative 1 exponent flips your fraction. All right, but this is more the why of that. This will factor. 3u times 1u is 3u squared. I need plus plus to get a plus on the end and a plus in the middle. I'm thinking 4 times 2 will give me the right middle term. Then set each factor equal to 0. That gives you 2 solutions of negative 2/3 and negative 4. And then, like I said, you have to undo what you were standing your variable in for. The real variable u, the u really stood for the variable x to the negative 1. So x to the negative 1 equals negative 2/3 and negative 4. And then to fix that situation, a negative 1 to a negative 1 makes x to the positive 1, or just x. So we also take this side to the negative 1, which negative powers flip the fraction. Okay, now they did not change the sign of the fraction, though, so make a good note on this. Negative 2/3 is still negative, it's just flipped, okay? Because on multiple choice tests, there'll be every combination of 2s, 3s, 4s, positives and negatives. You gotta be real sure about this deal. So when we factored it, we got negative answers. We set it equal to 0, we got negative answers, and then the negative exponent flips that. Still negative. Negative 3/2 and negative 1/4 for your 2 answers. Okay, any questions on that?